Hi everyone, welcome to my virtual classroom channel. This is Mr. Cervone. Today we will learn about 3D geometry part 1. So according to the do now, here we have a line drawn on a sheet of paper and a point on that line. How many lines can be drawn perpendicular to the line through the point? Well, that's pretty simple. So for part 1, let's say you have a sheet of paper like this. Okay, so imagine that's your sheet of paper. And then you draw a line here on the sheet of paper and a point on that line. Well, how many lines are you able to draw through the point on that line such that it's perpendicular to that line? Okay, so in this case, we can just draw one line such that it's perpendicular to the given line. Okay, so the answer is 1. And for number 2, are there any situations in which the answer to the first problem will be different? So what do you guys think? Well, there are situations in which it's different. For example, when you consider 3 dimensions, okay? So in 3D, this is actually different. So imagine that the given line here is the one shown here, line N, okay? So in this case, we have how many lines can be drawn perpendicular through that point? Well, we have a line here, we have a line here. Keep in mind that these lines are all perpendicular like this, okay? So this is perpendicular, so we can draw another line that is perpendicular. So the answer is infinitely many lines. So that's how many lines we can draw here for the second scenario where you enter the 3-dimensional geometry here. So in this lesson, we're leaving 2D behind and we will enter the 3-dimensional world. So in the do now, we talked about points and lines. Well, back in Unit 2, we tried to define points and lines, but we're able to come up with descriptions only. For example, how did we describe a line? So you remember in Unit 2, we had a line like this. We didn't really define it because we know a line is an undefined term in geometry, but we kind of described it as a set of infinitely many points that are all collinear. Okay, so let me write the word collinear, and extend infinitely in both directions. That's why you have this arrows here on the left and on the right. Okay, so that's how we define line back in Unit 2 in geometry. Also keep in mind that we described a line also to have infinitely small thickness. Okay, so there's no thickness. We're just modeling on a paper that such that it has a thickness here, okay, like this. And also another thing to note, we determined a line also, by 2 points. Okay, so keep in mind that when we want to determine a line, we had a point, 2 points, and we were able to determine a line. Okay, so let's see what we're able to determine in a 3-dimensional world. Okay, so let's talk about planes. So if 2 points determine a line, then what exactly determines a plane? So that's something to think about now. What determines a plane? Okay, so here we have an example of a plane in which 3 points are on the plane. Keep in mind that these 3 points are non-collinear, okay, which means that they don't lie on the same line. So one way of determining a plane is as follows, and that is a postulate. There is one and only one plane containing 3 non-collinear points. Okay, so again, 2 points determine a line, and 3 non-collinear points determine a plane. What if the 3 points were collinear? Do they still determine a plane? Well, the answer is no, because, or not necessarily, I should say, because if you have 3 points that are collinear, they actually determine a line, and that's it, okay? As soon as one of the points goes outside the line like this, then you can actually enclose it. Now you have a triangle, okay? But then you can extend each sides in infinitely in all direction, and now you end up with a plane. Okay, so keep in mind that a plane, we actually described it back in Unit 2, is a set of infinitely many points extending in two directions only. Okay, so here's a question or reflection. How do you determine a plane by means of lines and points? Because so far we have just noticed that you can determine a plane by three non-collinear points. However, there are ways to determine a plane also including lines. So let's think about this. Is there a way to determine a plane by means of lines and points? Okay, so one way to do this is as follows. Let's say you have a line and a point not on the line. So according to the postulate, there is exactly one plane containing a line and a point not on that line. So that is a way to determine a plane. How else can we determine a plane? If two lines intersect, then there exists exactly one plane containing them. So basically, if we have two intersecting lines, then we can determine a plane as well. And finally, another way to determine a plane, if we have exactly or two distinct parallel lines, and in which case we can determine a plane as well. The last postulate that uses two parallel lines to determine a plane brings us to a new definition in 3D. What does it mean for two lines to be parallel? Okay, so according to the definition, parallel lines in space are lines in the same plane that have no points in common. So it's very similar to the definition in the two-dimensional world. So let's look at an example. Let's say you have a cube. Which set of segments are parallel in this case? Well, one example is if you look at segment HG, that is parallel to segment CD, okay? Because they lie in the same plane. What about segment HG and segment AB? Are those two lines parallel? Well, it turns out that yes, they're parallel and they also lie in the same plane because you can actually draw a plane like this such that HG or segment HG and segment AB are in the same plane. Okay, so there are many examples in this particular figure in which the two segments are parallel. Now let me give you an example. Let's say you look at segment HG and segment BF. What can you say about these two segments? Well, if you look at HG and BF, well, they're definitely not parallel. Do they intersect? No, they don't intersect either. So in this case, if two lines are not parallel and do not intersect either in space, then these two lines are called skew lines. So the definition of skew lines is the following. Skew lines are lines in space that are neither parallel nor intersecting. What about planes? How do we define parallel planes or perpendicular planes or skew planes? Okay, so we learned this in the second unit that parallel planes are parallel or two planes are parallel if and only if the two planes do not intersect as shown in the figure. Similarly, perpendicular planes are defined as planes that intersect. And also, as you can see in the figure, two planes are perpendicular if and only if any two intersecting lines, one in each plane, form a right angle. So we'll talk more about angles later. Okay, what about skew planes? Is it possible for two planes to be neither parallel nor intersecting? Well, it turns out that in Euclidean geometry, planes cannot be skew, and basically that's it. That's the answer, okay? Okay, so let's define intersecting planes. Okay, if two planes intersect, then they intersect at exactly one line. So as you can see in the figure, here we have a line being created by the two planes. So keep that in mind because we will be using it later on. Okay, here's something for you to think about. How can we determine the angle formed by two planes? Okay, so there's a definition for that. It's called dihedral angles. A dihedral angle is the union of two half planes with a common edge. So here's something that needs to be said. When you create an angle formed by two planes, you want to draw a ray here and a ray over here on the second plane, okay? So it is very important to draw these rays such that they're perpendicular to the common edge, like this, as you can see here in the figure, okay? Only in this case do we ensure that the angle is measured correctly, and that is the definition of a dihedral angle. Because you can even have the following scenarios. Let's say if it's not perpendicular, so let me draw the two half planes. So let's say I draw one ray that goes this way and another one goes this way, then this angle here is not considered a dihedral angle because the two rays that are in each plane are not perpendicular to the common edge or the line that they intersect with. Okay, so here's the definition of perpendicular planes in terms of dihedral angles. Perpendicular planes are two planes that intersect to form a right dihedral angle. So notice here that N1 or ray N1 and ray N2 are each perpendicular of the line of intersections of the two planes as well. Okay, so let's wrap up this lesson with an example. So here's an example. Let's say you have point A, B, C, and D that are distinct coplanar points, no three of which are collinear. If E is a point not in the plane of A, B, C, and D, how many distinct planes are determined by the 5 points? Okay, so let's draw this out. So let's say you have a plane like this, okay? And let's draw these 4 points, A, B, C, and D, such that they're non-coplanar or non-collinear. A, B, obviously 2 points will always be collinear and coplanar as well. So let's put point C over here somewhere, and point D, we can just place it here on this plane. Okay, so none of the 3 points are collinear in this case. Point E is somewhere outside the plane, somewhere out in space. So the question is, how many planes are determined by these 5 points? And notice here it says distinct, okay? Which means that the first plane here is already determined. Plane A, B, C, and D. Okay, so that's one plane. Okay, what about the other planes? Well, we can actually draw a plane here determined by B, E, and C. So let's write this in, plane B, E, C. Okay, so let me erase that. Another plane that can be determined is plane CDE. So let me write this in, okay? Then there's another plane determined by A, D, and E. Okay. Then there's another plane determined by A, B, and E. A, B, and E. Are there any other planes that can be determined? Well, the answer is yes. What about plane ACE? There's another plane that we can determine here. And notice that this is a distinct plane. So we have plane AEC. And finally, we have another plane determined by the other diagonal here, so to speak. So we have plane B, D, and E. So how many planes are determined here? The answer is 1, 2, 3, 4, 5, 6, and 7. So the answer is 7. Okay, so that's all for today. I hope you enjoyed this video. If you liked it, click the like button and please don't forget to subscribe. And again, thanks for watching the lesson. Have a good day.